How could we do that? When we graph the system of equations, what are we looking for?
Where they intersect.
Where they intersect. And then we learned substitution. How did that help us? What did we do?
We found the coordinates like x and y
How?
by solving.
By substituting the value for either x or y. So today we're going to learn about, it's a new method that you're going to learn called elimination. Okay, so take a look at this. 2 espressos and 3 muffins cost $10. 2 muffins and 3 espressos cost $12. So let's say this is my order. Let's say I went into like Starbucks and ordered 2 espressos and 3 muffins. And then Mrs. C went into Starbucks and she ordered 2 muffins and she was really tired, so she ordered 3 espressos. Okay? How could we
look at the scenario? What did we pay all together? Like, what did we get? If we went together, she walked up to the counter, bought her stuff. I walked up to the counter, bought my stuff, but we sat together. Okay. Explain the overall to us. What did we get? We got 5 muffins. How did you get 5 muffins? Because Miss K got 3 and I got 2, so we got 5 muffins. So 5 of them. That's okay, you do it on the top. I didn't realize we can't write on that. So we got 5 muffins. And what else? And 5 espressos. And how much did we spend? $22. Good. So what did you do to figure that out? Just add it all together because that makes sense, right? Her coffee and her muffins equal that much money, and my espresso, not coffee, and muffins equal that. So all of our muffins and all of our espresso would have to equal all of that money. Okay, good. Do you think there's a way that we could figure out the price for just 1 muffin and 1 espresso based on what we're looking at now? There's a way. And it's today's lesson. So keep this scenario in mind because we're going to go back to it.
Okay, so you can add 2 equations together. If we look back, that's exactly what we did here. We added these, if these were equations, we added them together and got a total number of muffins and total number of coffees and the total price.
So you've already proven to us that you could do that. And you can.
So we can add these equations together. We have 4 x's and 2 y's gives us 6 x's. And we have negative 2y plus 1y is negative y. And then we add our total. We have 4 plus 6 is 10. We can add them all together. Alright. So I want you all to try and add this system of equations, add them together. I want you all to try and see what
And
you
what's
get.
your new equation? So add them up, write it down. Good examples to have in your binder because we're going to go over a few different examples. If you combine them, what is your new equation? So write it down and see if you notice anything. But just write down what you have.
Okay. So what do we get?
5y equals 5.
What happened to your X?
It went away.
It went away. Myra said it canceled each other out. Why did it do that?
They're inverse.
So they're the inverse, they're opposites. And what happens when we combine 2 opposites, no matter what they are? They become 0.
So can we find out either of these variables now? What the value is?
Yes.
What do you know?
Because you always know that I think it's identity property, I forgot what it's called. But it was like anything you multiply times 1, you get the same answer. So like you can make it inference that 5 times 1 equals 5.
So y is what?
1.
And if you wanted to just solve the equation the traditional way that we have, and you divided both sides by 5, you would also get that y is 1. So look at what you just did. Without really knowing it, you took equations that had 2 variables and you turned them into what? An equation with only 1 variable. So again, think back to substitution. When you add equations with 2 variables, difficult to solve for. But when you add an equation with 1 variable, you're able to find the solution. Much more straightforward. You just did the same thing.
Alright, so now we have one value. We have a value for y is equals 1. Can we find the value for x now? How do we do that?
So that's two being one and two is the two.
Yeah, we can substitute y in for either of these equations. So which one do we want to do? Okay. So now we have x plus 3 times 1
Just three.
equals 2. So what is x equal to? Alright, so we subtract 3. We know that x equals negative 1.
So why were we able to get a solution here, but on the previous slide, we still had an equation with 2 variables? What's the difference? So we added the equations here, and we got 6x minus 1y equals 10, right? So we just added them. But then we did the same thing on the next slide, and somehow we came up with a scenario where our equation only had 1 variable. How did that happen? What's the difference between the 2? So we gotta take a look at that equation. When we added them, it became 5y equals 5. All of a sudden, we didn't have the x. But on the previous slide, when we added them, we still had 6x minus 1y equals something. What's the difference? Because this is the key to elimination.
Because the coefficients of x in this problem compared to the other problem are inverse of each other, they're opposite, so they just end up canceling themselves out.
Okay, so they ended up canceling each other out. And what happened on the last slide?
They just
Because notice those, what do you notice about those coefficients?
they're positive.
Okay, so they're, well, not all of them, but the 2 is negative. Okay, but what happens when you combine them? Do any of them cancel out? No, but then on the next one,
One cancel out.
one of them did, and you picked it up. You said the coefficients were opposite or inverse. They were opposite. So, and we know that when we combine opposites, we get 0. So that's a key component as we move forward.
So now let's try a new one. We did that. Oh, so the 3 methods now that we already talked about this. The 3 methods that we can use to solve systems of equations are graphing, substitution, and now today we're gonna learn about the elimination method. So we just did it. When using the elimination method, you want to eliminate one of the variables by adding the 2 equations together.
So you guys are referring to it as canceling out, but really what you did is you eliminated one of the variables by making one of the variables 0. Sometimes it's very straightforward. Sometimes we may have to do a little bit of work, but if you think of the process, like the process of substitution, you're actually substituting a value in to solve. The process of elimination, you're going to eliminate a variable to solve. So the name of the strategy kind of tells you what you're doing. I'm starting to like it more.
Some people call this, you might hear it called the addition method. Sometimes, if you're researching online for extra practice, you might sometimes see it's called the addition method.
But in here we'll refer to it.
Yes, and here we'll refer to it as the elimination method. But you're adding the 2 equations together to eliminate the variable. Yes.
Would you also subtract the 2 equations to get a variable on as well?
You can. Okay, that's it is another form of elimination. In 8th grade, we primarily focus on the addition part.
Okay, so now let's try this one. This is another system of equations. 3x minus 4y equals negative 5, and negative 10x plus 4y equals 12. So try this one. See if you can solve this system of equations. We want to find a solution.
No, you're still not there. It has to be all. Because remember, when we went to the store, it was all of our espressos together, plus all of our muffins together, with all of our money. Every. Once you get that value, you can go back in and find your second. Are those plain or good? It's like just a big solid.
Oh, yeah.
Every time you eat them,
So what's the first step in solving this using the elimination method?
and for those of you that struggle with why we're combining, think back to the scenario of the espresso muffins. If Miss K bought her espresso muffins for a certain amount, and I bought my espresso muffins for a certain amount, then all of our espresso and all of our muffins would have been the combination of our two amounts.
Combine like term. Thank you. I mean, yeah.
So walk us through that.
What are we doing to these two equations? Alright, so we're gonna add them together. So what do we get? So we have 3x minus 10x is negative 7x.
Because we added a negative, which is the same as subtraction.
And then that's
Okay, so then negative 4y plus 4y gives us nothing, so plus 0. And then negative 5 plus 12, so 7. Alright, so now what can we do?
What's x?
Divide by half.
So x is?
Negative 1.
And if x is negative 1, what's y? Because we're not done yet, remember, we need to find the x and the y. The solution to a system is what? Oh, I just said any solution, but you're right. If x is negative 1, y is
How did you get that? What did you do?
substituting x. Substituting.
Yeah, so you're substituting this negative 1 in for any x. Which equation did you use?
First one.
The first one. Okay. So instead of an x, we actually have a negative 1. So now what can we do? What is this equation now?
What's the equation now?
Negative
Negative 3 minus 4y equals negative 5. And if we solve,
Add 3 to both sides.
so negative 4y equals
Negative 2.
negative 2. So y is
1.
positive 1/2.
So this is our solution. When x is negative 1 and y is 1/2, that coordinate is on both of these lines. It solves both of these equations. Solution to both equations.
So why did elimination work here? What happened when we combined our two equations?
we had, one of the variables had equal, had the opposite, coefficient, so they cancel out.
Good, so one of the variables in this scenario, and it was the y variable, had opposite coefficients, a 4 and a -4. So we eliminated the y variable. Do you think that will always happen? No, you can probably think of other systems when we've been substituting where we didn't have the opposite coefficient.
Let's take a look at this one. This is actually the one that we added together in the very beginning. Does anything cancel out when you add these together? Does anything eliminate? No. So how do you think we can manipulate these equations to make one of these variables cancel out?
Think back to the first unit. When we talk about solving an equation, what is the basic premise when we solve? We know a few things based on unit 1. When we have an equation, whatever's on one side is the same as the other. And in terms of solving, what do I know always stays true? How do they always stay equal? Think about the basic component of equations. Like if I multiply one side by 2, am I good? Why am I not good? I have to do the same thing to both sides so that my equation is what? It's still balanced. Right? Can I do that at any point in time? Yeah, whatever. I could add 1,000,000 to one side of an equation as long as I add 1,000,000 to the right side of the equation. So think about that as you try and find a way. Is there a way to manipulate one or both one of these equations so that we can eliminate? That's a lot of big words. Can we manipulate so that we're able to eliminate? That's really weird. No.
So everybody look at these equations. What do you think we can do to manipulate one or both of these equations in order to eliminate a variable?
What do we know in order to eliminate? What do we need? What do we need in order to eliminate?
The same coefficient for one of the two variables,
Is it the same?
not the opposite coefficient.
So we need, for one of the variables, the coefficients to be opposites. Okay, so let's talk about the coefficients we have. What are the coefficients to x?
2 and 4.
2 and 4. And then the coefficients for y?
1 and -2.
1 and -2. So let's either one. Is there any way that in one of those equations we could do something so that one of the variables becomes the opposite?
If you add one y to the first equation,
Are we allowed to do that? Like in think about what we do. Like what
make it to both
operations.
sides.
Okay, so let's do something to both sides. You're definitely on a good track. Okay, what do you want to do to both sides? Now remember, the goal is to get rid of one of the variables.
So you could add a y, or you can make your 2x into 4x by adding 2x.
Okay,
No,
so let's
if we added 2x over here, we have to add 2x over here. When we added these together, we have.
Are you going to be able to get rid of your variables? That way you're on the right track because you're thinking about ways that you can manipulate. Okay? But we're focusing more on the coefficient than the variable. So that might help your idea. You're focusing on the coefficient.
Can't you multiply 2x plus y by 2 and do it to the other side?
By 2, think about what we need to eliminate. We need opposite coefficients.
Oh.
So if the bottom is a 4x, what do we need to do to the top?
You get negative you get by negative.
We need it to become a negative 4x. Good.
So
The top. He said multiply the top by negative 2. At first he said positive 2, which I made the same mistake. Miss K actually taught me elimination the other day because I hate elimination, so I only do substitution. And I kept trying to make them the same number, like a 4x and a 4x, and it took me a while to realize the only way they'll make 0 is if they're opposites. So that's probably a common mistake because I seem to keep making it too. But that'll become a negative 4x now.
is there another way we could have done this? Did we have to multiply it by the -2?
We could have multiplied it by 2,
And what would that have done?
canceled out the y's.
Cancel out the y. So if we multiply it by -2.
They'll cancel out the
Wait, what would our new equation be? We multiply this entire thing by -2.
negative 4
or no, because it'd be negative 2.
Minus 2y equals negative 12.
So do you see why that equation, so the negative 4x minus 2y equals negative 12, that's the new top equation. So now our system is really like those two.
And when we add these together, we can easily eliminate that x. So if we did it, so the way I did it was the way Manny did it, was I multiplied by 2 on the top and to eliminate the y's. You can do it either way. You can manipulate either variable as long as you're canceling out one of them, because we only know how to solve equations that have one variable right now. So we just need to eliminate one variable. So here I multiply the top by 2, and then my new equation was right here. It's 4x plus 2y equals 12. When we add those together, what do we get?
We can
8x equals 60.
Do you see how the 2y and the negative 2y cancel out? Do you see how here, if we added these two together, what would we get?
You would get negative
Negative.
4y
Equals 4 minus 12, negative. So what does y equal?
2.
2. So you can use either way as long as you just need to eliminate one of the variables. And then we can use that variable. So now we said x equals 2.
Now we've done it two different ways, which is why we keep going back and forth between one way and the other. So if you're writing a method down, make sure you're writing it clearly, because we're bouncing from one way to another way. Okay, just be clear of that.
Alright, sorry if that was confusing. I was just trying to show you that, so show you Manny's way and Gustavo's way. So Manny multiplied the top equation by 2, Gustavo multiplied by negative 2. So they were eliminating different variables. So now that we have one, so we use Manny's way and my way. If we have one of the variables, x equals 2, how can we find the other one?
Because we're not done, we only have one of the variables.
Now you can substitute x into either one of the equations.
So now we can take x and substitute it anywhere you see an x. We can replace it with
What value?
with 2. Alright, so which equation do you want to use?
Second.
Okay, so we want to use the second one. So anywhere you see an x, there's actually a 2 there. So what's our new equation here?
8 minus 2y equals 4.
8 minus 2y equals 4. Now we can solve and find our value for y.
Subtract 8. Negative 2.
Y equals 2. So our coordinate is x is 2 and y is 2. Coordinate 2, 2. Does anyone have any questions on this?
So when you eliminate, sometimes you don't need to do anything to either equation, because if you already have what, you're good. Like when would I not need to multiply one of the equations? And I can say like I don't have to do anything except add it together and I'm going to find a value. When would that happen?
When your two coefficients are already opposite. from
When
each
one of my variables already has coefficients that are opposite. If I can just add them and find and eliminate, I'm good. But I may not always be that way. In this scenario, what did we have to do? We needed to do something because none of the variables already had an opposite coefficient. So we had to do something. And we know going way back to Unit 1 that I can do anything to one side of the equation as long as I do it to the other. So you could multiply here And you could find, and you didn't even have to multiply the top equation, you could have actually divided the bottom equation by 2. Right? If you divided the bottom equation by, well, actually -2, you could have also canceled out or eliminated variables. So there's options, but the goal is you're manipulating. Now there may also be scenarios where you need to do something to both equations. And we'll look at an example of that later, but remember the goal is you're going from 2 variables to 1 variable by eliminating a variable. That's why it's called elimination.
So now let's go back. Oh, okay. So let's go back to our coffee order here. I want you to write an equation for each of these orders. And then solve using the elimination method. So you may need to manipulate a little bit.
Work together, because this one might seem like a little straightforward. This is a challenging one. We want you to work together and see how you can eliminate one of the variables.
To do the
Yeah.
We'd rather do the DOL or the practice.
Yeah, we'll have to do the DOL to see. And that'll be good because you can kind of see like where they're at.
Some of them might like this one better.
Yeah, I think it depends on which equation. Because like if it's already in slope-intercept form, I think they're gonna want to substitute. But if it's in thin X,
When I learned this, I never, like I only just realized when I was just
Mhm.
making these that like, oh, it depends on the equation.
Yeah,
Whichever one's
that it
easier.
depends.
Yeah. Like they don't, like my, whoever taught me this didn't stress that, to use it when it's easiest.
Right.
Whichever one.
for our last class, I would take out the slide where you showed them how to do it, or add the other way on the other side. Because like you only showed them one way, but they actually came up with the other way. So then you went from that to the other way, and then back and forth, and like Gisela is really confused because she's trying to write it down. That's why I was like Jamie's trying to write it down. So that's why I was like, if you're writing it down, so what you could do is if you saw, like, leave the next slide blank, so that if you get 2 ideas, do them side by side.
Okay.
You know what I'm saying? And then actually it works too because you're gonna have them drive it, like drive the discussion. So you're never telling them how to do it. They're actually telling you how to do it, but you're showing them both ways.
Okay.
Because that's the tough part. Like you don't want to predetermine like where they're gonna go.
Because you don't know.
Because like what means
Yeah.
said divide the bottom equation by 2, and then on the next slide you're like, oh no, I just multiplied. Like it's hard because you don't want to turn them off
Because they can do.
because you put something on the next slide. But so, and I learned, like I do that all the time. But I've tried as I've gone over to actually put less in the PowerPoint because, or in the slide, because if they drive it, like you want to just go with what they do and then show them another way. Because you could like that one, you can multiply by 2, you can multiply by -2, you could divide the bottom one by 2, you could divide the bottom one by -2. Like there's actually a lot of ways.
Yeah.
And you just never know
What they're gonna say.
which way they're gonna go.
Uh-huh.
And then it's cool because when you start to do that, your classes will actually move in totally different directions.
Yeah.
Like you'll have one class who says divide, and then you'll have one class that says multiply, and you're gonna end up teaching 2 different lessons in a day because they're actually teaching each other. And it's kind of cool when that happens. And it's the less you provide, the more they actually like drive it. It's actually really cool. But when I heard him say to cancel out the X's, that's when I was like, okay. And then when he said to cancel out the Y's, perfect time to pull. And you even did it because you were like Manny's way and Gustavo's way. So then think about on the next slide having nothing and then just writing out Manny.
Yeah.
So someone explain to us what Manny wanted to do. Someone explain to us what Gustavo wanted to do. Because you're always going to have, you're never going to have all the kids agree. So it's kind of nice to have that healthy debate. Like, which way's better? I always ask, like, what do you like better? And then you'll have half the class say, like, that one. Why? I don't know, it just seems easier, right? You know, then you kind of get the whole.
When you guys did the negative too. I was like, oh, I really want to show them that because I'm in a negative.
And you know what? When he said it, I did the same thing because I tried to eliminate the X's because it was the first one I saw. And that was the only reason. I knew, like, just looking at the equations, 2x and 4x, I knew I can make that opposite. And then, like, whereas you thought more like, don't multiply by a negative, just multiply by a positive, right? So, like, that's why you're why. So, like, the thinking is cool to see how they think differently. And you want to show that as often as possible. And that comes with experience. Like just to it's hard to put less up because when you're teaching it for the first time, like you need as much structure as possible. And then you find that like as you get better at it and the more you do it, you can put less in knowing that like you kind of know where you want them to go with it. And that took, I mean, like it's taken me a long time. My first year, everything was like to the point, like everything, because I didn't know how to teach it.
Yeah.
And then as I got comfortable with the kids, I was like, okay, well maybe like I can have them figure this out, so I won't put that in. I won't tell them this. I'll see if they can, or I'll ask questions to get it out of them.
Yeah.
And like you're getting better at like pulling the answers that you want out of them by asking certain questions. It all ties in. Yeah. It's actually a really good lesson. This is a good one for him to see because they're literally coming up with the method by themselves.
Yeah.
And the last class, they're going to be very inquisitive. So like in the last class, you're going to have like a million different options,
Yeah.
which is going to be cool for him to see.
Alright. Okay, so let's take a look. What are the equations that we came up with here? What's for my order? The 2 coffees and the 3 muffins. What is my equation?
2x plus 3y equals 10.
So 2x. So the x's are the coffees. Plus 3y. The y's are the muffins. Equals 10. I paid $10 for all that. Alright, and then what about Mrs. Caravaggio's?
I put 3x plus 2y equals 12.
3x.
I like how you switched the order there, knowing that we want to try elimination. You kind of put the x's with the x's, the y's with the y's.
Okay. Yeah, because the x's represent the coffees. Good. So we want them to be on top of each other like that. So we can easily, when we add them together, we can see what we're doing. When we manipulate, we can see like what the coefficient of x's are, what the coefficient of y are, what we want them to be. So how do we manipulate these? Can we just add these together and cancel out one of the variables? When we add these together, do we cancel anything out? Do we eliminate any variable?
What do you get if you add both equations together? 5x plus 5y is 22. So nothing easily eliminates. So what do we need to do? What did we do during the lesson when the equations didn't easily eliminate?
Right, so if we multiply, what do you want to multiply by?
The first equation, I multiplied everything by -2.
The first equation, Leo multiplied everything by -2. Okay.
What did you get?
Wait, no, sorry. No, -3.
-3?
All right. He wants to multiply by -3.
Okay. So when we did that, what did we get? What's our new equation?
Negative 6x minus 9y equals -3.
So why did Leo do that? Because when I'm looking at this now, I have -6x minus 9y as my variables, but then the other equation, I only have 3x and 2y. So what gives here? Another group. Who else can see what the option is? Like why did he do the -3 to the top equation? Because we can't easily eliminate. Is there something else we need to do? Jayla, what do you think? I see you have a question.
Well, would you multiply the second equation by +2?
If we multiply the second equation by +2, look at what happens to that second equation. What does that equation become? 6x plus 4y equals 24. So what do you see now? Can we add them together and eliminate something?
Yes.
Yes.
Yeah, what can we eliminate now? The x's. The -6x and the 6x make a 0. So our equation becomes what?
-9.
So -5y equals -6. So how do do we solve for y? Divide by -5. And what do we get? Y equals, which is what? In terms of money, because this is money, we're talking about the cost, and our Y was the muffin. So how much was each muffin?
$1.20.
$1.20. 6/5 is 1 1/5, so it's $1.20. Now, did we have to do exactly that way? No. There's actually like a lot of ways.
We multiply the top one by 3 and the bottom one by -2.
Yes.
Did anyone do it another way? Did anyone do it another way? Did anyone not use like the 2 or the 3? Did anyone cancel out the y's instead of the x's? There's a lot of different ways you could do this.
You could have actually, I mean, this is like crazy, but if you wanted to, if you saw like the 2x at the top, if you wanted to make that 3x into a -2x, you could have actually multiplied by -2/3, right? If you multiply the entire bottom by -2/3, then the x's would have become -2x, right? Like, but again, not a lot of us think to go fraction, but you could have. There's a ton of ways, but remember the ultimate goal. What's your ultimate goal? Whatever you do to either one or both of the equations, what's your goal? What's your end game? Why are you going to do anything to either equation? Because your goal is to eliminate one variable. We want to eliminate one of the variables. So now we know our muffins are $1.20. How do we find the amount of our espresso? Do you have a question or are you going to keep
I have
going?
a question.
Yeah.
Is there any like scenario where you would have to do like a multi-step kind of thing, where you would have to like maybe multiply or like divide or something, do 2 things instead of just 1 step, or just only do 1?
Well, here's the thing. On the like, if you do what I had just said, if you wanted to make that bottom 3x into a -2/3, some people might think to like multiply by -2 and then divide by 3, because that's the same thing as multiply by -2/3. But you could condense it to 1 step, no matter what. You'd be able to.
Does anyone have any questions about the elimination method?
How are you going to find the amount of the espresso? Let's go back up to the top. If the muffins are $1.20, what are you thinking? Go ahead.
I want to substitute y into the second equation.
Okay, so we can even just cover right over the muffins. For the muffins, it's $1.20 and $1.20. So how much are the muffins total? That's my order, right? Mine was the bottom one?
Oh,
Yeah. So I spent $2.40 on muffins. So how much did I spend on coffee? If $2.40 was on muffins, and I spent $12 total, how much did I spend on coffee? Good, perfect. $9.60. So how much was each coffee? $3.20. Good. Now you could substitute in and solve an equation. Some of you can see the picture and kind of do that, knowing that you shopped before and can kind of make change. You could have done that. Either way, if you had to substitute in and take your time with it, that's fine. Some of this could be a little bit more time consuming. That's okay.
So, all right. So we actually have like 3 minutes left, so I just want you to do the first one. Or the second one.
Yeah.
Alright, sorry, just the second one. Solve using the elimination method.
Okay, use the, okay. 20.
Should just. I wanted to pause that, but I'm not going to now.
The 16.
Bell's gonna ring in about 30 seconds. Sorry, I know we ran out of time a little bit because we have a shortened day today.
You can't spend all this time.
Put what you have in the bin. We're not gonna grade. Don't worry about. Just we want to see whatever you're starting to do.